Hello all, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In previous video, we have discussed about trackers, tracker characteristics and the performance of trackers and the parameters which affects trackers. And today in this series, we are going to discuss about the types of trackers. Here, now I am going to discuss about the magnetic tracker. First one, a magnetic tracker. It is a non-contact position measurement device that uses a magnetic field produced by a stationary transmitter to determine the real-time position of a moving receiver element. It might be AC or DC. See here, the trackers are used to calculate the time coordinates of real world as well as the VR world. Here, magnetic tracker is a kind of tracker. It has both transmitter and receiver, and it uses magnetic field to determine the real-time position of moving receiver element. Here the transmitter is stationary and the receiver is moving. It might be AC or DC. Okay, what are the characteristics of magnetic trackers? In magnetic trackers, it uses low frequency magnetic fields to measure position. Your second thing is fields are produced by a fixed source. And your third thing is size of source grows with the tracker work envelope. And your fourth one is the receiver is attached to the tracked object and has three perpendicular antennas. Actually, what do you mean by antenna? What is the use of antenna here? Antennas are used for transmitting and receiving purpose. Here we have both transmitter and receiver. In magnetic tracker, transmitter is stationary and receiver is moving. Here the distance is inferred from the voltages induced in the antennas and it needs calibration. Okay, see here a magnetic tracker with the old data globe. See, here we have electronic interface and transmitter and receiver. From transmitter to optoelectronic interface. Why it is optoelectronic? Here we have optical fibers for connection purpose. Okay, so optoelectronic interface and which is connected with optical fibers, and we have the wrist position and orientation signal because it is a globe, a magnetic tracker with old data globe. So we have wrist position and orientation signal. This signal is passed with the help of optical fibers from receiver into electronic interface. Here we have receiver at the wrist side, at the hand side, at your wrist side, receiver. And here the wrist position and orientation signal which can be passed through optical fibers and which is interfaced with optoelectronic interface. In this electronic interface part, we have on or off switch and reset button, and also we have RS-232 host computer. Here we use the port RS-232 to connect with our host computer. And also we have transmitter end. We have stationary transmitter and moving receiver. Here the moving receiver, this moving part, moving receiver, which is called a hand glove in magnetic tracker. Here we use that example. So we use stationary transmitter and moving receiver, that is a wrist. Here with the help of optical fibers and optoelectronic interface, we can map our transmitter and receiver. The transmitter can transmit or send the signals through this antennas, transmitting antennas, and with the help of transmitter and the mediums, with the help of the waveguides, we can easily acquire the signal at the receiver side based on the user needs, based on the user's wish. We can change our data. With the help of this magnetic tracker, we can track only the stationary transmitter and moving receiver's position only. Here the example is old data globe. It is a perfect example for magnetic tracker. Okay, here magnetic tracker accuracy degradation. Here we have accuracy A1, A2, A3, A4 based on the surface of equal accuracy and ferromagnetic object based on that ferromagnet and the magnet which is used to produce magnetic field, and the surface the accuracy might be differ. Okay, and next we have the comparison of AC and DC magnetic trackers. Here DC trackers are immune to non-ferromagnetic metals, brass, aluminum and stainless steel. Both DC and AC trackers are affected by the presence of ferromagnetic material, mild steel and ferrite. Both are affected by copper, and AC trackers have better resolution and accuracy, and AC trackers have slightly shorter range in compared to DC. And we have some examples for how to select a tracker. Yes. With this, I'll stop. In the next video, we are going to discuss about the other types of trackers in virtual reality in medicine. Thank you.